Okay, in this video, what I'm going to do is show you how we can use JUMP to perform a hypothesis test for the population mean using the t-distribution. However, we're going to do this when we have the summarized statistics rather than when we have the raw data. What I'll do is I'll create another video with using raw data to perform a hypothesis test in a separate video. So let's give a look here. This is about time spent on Facebook. So it says Facebook.com claims that users spend a mean of 55 minutes per day on the site. A communication professor believes this claim is too low. All right, so in other words, this professor feels that its users are spending more than 55 minutes on the site. To test the claim, she surveys 49 users and finds they spend a mean time of 58 minutes with a standard deviation of 10 minutes. All right, so that mean and standard deviation, remember, are on those 49 people. So those are sample statistics. Question asks, do these findings support the professor's belief? Use a 5% significance level. All right, well, these 49 users right here, obviously that's our sample size, and then those 49 people created the mean. So that's an X bar, as well as a standard deviation. So that standard deviation of 10 minutes is a sample standard deviation. And remember, when we're given the sample standard deviation, we use the t-distribution. All right, so then you say, well, what about this mean up here? You know, the mean of 55 minutes per day. Well, that's the mean for the population. That's what Facebook's claiming. All right, so let's start filling out our template. So as you can see, our template, I've created one of these templates for virtually every hypothesis test that we're going to do in a course. This template actually does two. It tests means for using the t-distribution and using the normal distribution. And that's decided, as you see down here on the left, where it says, you know, what distribution you're using. It picks your brain on that. All right, so the first thing the template looks for is the hypotheses. All right, so the null hypothesis, the statement about the population mean that is assumed to be true. Right now, it's assumed to be 55 minutes. This communications professor says, you know, I think it's more than 55 minutes. I think that claim is actually too low. All right, and she backed herself up by grabbing 49 pieces of data, getting a sample mean X bar of 58, and that standard deviation of those 49 pieces of data was 10. So remember how the game works. When you're given the sample standard deviation, we are going to use the t-distribution with n-1 degrees of freedom, and there's 49 pieces of data, therefore there are 48 degrees of freedom. Now, to get the critical value for this, remember we have to go to the t-table for that. So we have to know that, first of all, alpha is 5%. And you can see right here it says Z or T, you know, your critical score. Well, we're going to be grabbing a critical t-score from the t-table, or we could use the TI graphing calculator. It has a feature in it, well, the TI-84 does, has a feature called inverse T, which will give us the critical score. To be honest with you, we don't need to do either of those because JUMP will find that for us and give it to us. As a matter of fact, JUMP gives us the critical score, the p-value. It'll give us the confidence interval if we ask for it. It gives us the testing statistic, you know, that crunches that number for us. And in fact, it even tells us whether we should be rejecting or failing to reject the null hypothesis. All right, so let's go ahead, and I'm going to use the TI graphing calculator to grab the critical value. So what I like to do before I use the calculator or ask the calculator to find the critical value for me, I like to draw my picture first because it helps me visualize what's going on. So what I'm going to do here is, if we look at the direction of the alternative, which is a greater than, that means a right-tailed test. So remember, if it was less than, it would be a left-tailed test. And if the alternative hypothesis was not equals to 55, that would be a two-tailed test. So I'm going to draw a vertical line straight down here and shade a critical region to the right. And remember, this critical region, I know that area is given to me, and it's 5%. That's alpha. And by common sense, this is confidence over here, which is 1 minus alpha, which is 0.95. Now, there is a score right here called a critical t-score, which is going to separate the critical region from the non-critical region. That's the thing I'm looking for. Now, again, how do you find this critical t-score? Well, JMP is going to hand it to us. But I'd like to know it up front, since we're talking about it here. You know, when you're doing this on your own, you're probably just you're gonna dump all this information into JMP, and you're gonna see all this information at the same time. In other words, like I said before, what JMP is gonna do is it's gonna give you, at the same time, you're gonna give JMP this information over here. You're gonna give JMP that information, and it's going to give you the rest of the information. But, you know, being that we're talking about it, I figure let's just go ahead and calculate this value. So in the TI calculator, in the distribution menu, if you hit second vars, there's a feature called INV-T. So I'm going to use that feature, INV-T. And it says, okay, area. What's the area? Well, the area is always the area on the left. So when you look at it, this t-score that I'm trying to figure out, the area on the left of that t-score is 0.95. All right, so that would be 0.95. And then it wants to know the degrees of freedom, which in this case was 48. So I'll let it do its thing. That score is approximately 1.68. I'm rounding here. So this number, 1.68. And it goes right here, 1.68. All right, so now what is this thing called the decision rule? What's that all about? Well, this lets you know when you're going to reject the null hypothesis and when you're not going to reject it. So remember, according to the central limit theorem, if here's the center right here of our distribution, the probability of landing far from that center is very, very low. When we do land far from there, something's wrong, and the thing that we think is wrong, obviously, is there's something wrong with the original statement. So if we land in this region out here, you know, landing out here is very odd. This is where we're going to reject the null hypothesis. And otherwise, if we land within confidence, we'll fail to reject. Remember, the decision rule is based on the null hypothesis. And that's this little statement right here. The decision rule says we're going to reject the null hypothesis HO if the testing statistic is greater than 1.68. All right, so there you have it. So now, what goes on with this? Well, we could crunch this thing by hand and, you know, calculate the testing statistic by hand or with the calculator and see where it lands and then pass our judgment. But like I said, JMP's going to do all this for me. So let's go ahead and go to JMP and get this info in here. And, you know, JMP's going to give us this output. So I'm going to go to JMP. And in our add-ins menu, there's our statistical calculators. And one of them says hypothesis test for one mean. So that's what I'm going to grab. And now the first thing it says is, you know, what are you giving me? Are you giving me raw data, or are you going to give me summary statistics? All right, well, we have the summary statistics. So I'm going to say, okay. All right, well, the menu's pretty basic. It says, all right, what kind of test is it? We've already established it's a t-test. The next thing it says, okay, what kind of alternative hypothesis do we have? Well, we have a greater than scenario. You want to reveal the decision? Well, maybe in the beginning you don't, so you could kind of work through that on your own. We could toggle that switch on and off. That doesn't matter. All right, the hypothesized mean. All right, we know that was 55. The sample average was 58. That's the sample mean. The sample standard deviation, I forgot already, of course, is 10. The sample size was 49, and the significance level, alpha, 0.05. All right, so the second I click somewhere else or hit enter, you're going to see the test results. It's going to populate all that with information, so I'm just going to hit enter, and there it is. Now, I have the reveal decision checkbox unchecked. If I check it, it tells you what to do. Reject the null hypothesis. All right, so it's a reject scenario. Now let's talk why. Let's see what's going on here first of all. So first things first, the t-score, which is 2.1. All right, so let's go over here. Oh, by the way, sorry. One other thing we should do while we're here, why not? Oops, sorry about that. The t critical value, 1.6772. There we are, 1.68. On the calculator when we did it, it was there, 1.6772. So JMP does a great job with that, as you can see. It hands you that value, so we don't have to go to a calculator. We don't have to go to a table. You can just grab it. It gives you the t-score. Now, what's the t-score? The t-score is this testing statistic. Now, that testing statistic for this kind of a test is either a z or a t, because remember, the values along this axis are t values. All right, so if I was to plug the numbers in, which is x bar, which is 58, subtract 55, over, in this case, s, which is 10 over the square root of 49, if you work that number out, you are going to get 2.1. Now, where does that 2.1 land? Well, this is a number line on the picture, right? So this is going to land somewhere over here. In other words, the testing statistic lands in the critical region. And when the testing statistic lands in the critical region, the decision rule above it says, reject the null hypothesis. And there's the result of your test. Reject H sub 0. Now, of course, JMP told us that. When I, checked the, reveal decision box, reject the null hypothesis, it did that for us. JMP will not do the final conclusion for us. However, it'll reveal the decision. Now, there's one other piece of info, actually two other pieces of info that I didn't talk about in the output. The standard error of the mean, 1.4286. That number right there, standard error. All right, well, that's actually this denominator here, the 10 divided by the square root of 49. Remember, that's called this standard error. It's called sigma over radical n. It's either sigma over radical n, or in this case, it's s divided by radical n. All right, so regardless, take 10 and divide it by the square root of 49, which is really 10 divided by the number 7, and 10 divided by 7 is about 1.4286. All right, so it gives you the standard error, and also it gives you the p-value, which is 0.0205. So that goes over here, the p-value, 0.0205. Now remember, the traditional method of hypothesis testing says if the testing statistic lands in the critical region, then reject the null hypothesis. Alternatively, if the p-value is less than alpha, which in this case it is, the p-value is smaller than alpha, you reject HO. All right, so now what? Well, finally, what's going on? So what I like to do is I come right next to the null and I write what we're doing. I'm rejecting this. I'm rejecting the claim that the population mean is 55 and accepting the alternative that the population mean in fact is greater than 55. All right, so now I could word my final conclusion. Based on the given information, the population mean time spent on Facebook is significantly greater than 55 minutes per day. All right, so now, as you can see, out of all the stuff that we've spoken about, there is one last thing, which is a confidence interval here. Now, there's a little issue with this confidence interval because this is a right-tailed test. This would warrant a one-sided confidence interval, and we're not going to speak about one-sided confidence intervals until the next section. So we'll have to hold off on this part for now. But I hope this helped you out understanding how to use the template to complete a hypothesis test, as well as using JMP. If you have any questions on this, feel free to send me a message. I'd be happy to help you out. Thanks for watching.